Hi everybody. So in this video, we're going to look at the sums of series for squares and cube terms. So I showed you in a previous video how we derive this formula. In this video, we're going to use these two formulae which are provided in the Edexcel formula booklet. So we don't need to be able to derive these, although we can prove them using proof by induction. Okay, so for example 1, we've been asked to work out the formula for the sum of a series r squared between the first and the 20th terms. So we can see that if we're looking at the sum of r squared, then we can use this formula in terms of n. And we can identify the n as the limit of our sum, which is up here. So in this case, n is 20. And then all we do is we substitute this 20 into this formula. So the sum will be 1/6 of n, which is 20, multiplied by 20 plus 1, multiplied by 2 lots of 20, also plus 1. And we can work out each bracket, so we get 1/6 of 20 multiplied by 21, multiplied by 41. And this works out as 2,870. For the next part, we've been asked to work out the sum of a series between the 8th term and the 20th term. But this formula only works when it starts from the first term. So we can write this as the sum of the first 20 terms from 1 to 20 of r squared, and then we can take away the sum of the first 7 terms. So we've got all 20, and we're taking away the first 7, so what we have left is the sum of the 8th to the 20th term. We know this works out as 2,870, and we can work out this one by letting n equal 7, which is this 7 here. We'll substitute this into our formula again, so we get 1/6 of 7, 7 add 1, and 2 lots of 7 add 1, which is 15. We can work this out, and we get 140. So we take this 140 away from the 2,870, and the total sum will be 2,730, okay? So that's how we use the summation of r squared. In the next video, we're going to look at using the summation of r cubed.